In this video, we are going to be talking about how to make our own properties and indexers. We've already seen a little bit about how to make properties. We haven't seen indexers yet. We're going to talk about making read-only properties and indexers. And we're also going to be talking about how to give properties an initial value. And like I said, we saw in video 12 how to make a property, but we didn't really go into any details. So let's do that now. Let's go back to our player class, and we'll take a look at the properties that are there, or the property, because there's only one. All right, here we are once again back in our Hangman example, looking at the player class. You recall we had a constructor. The constructor does one thing, which is assigns a value to the name property. We have another constructor that just calls the first constructor. And we have this property declaration. Now, in its very simplest form, and this is as simple as it gets, a property declaration looks like a field declaration, except that immediately following the name, it has braces and then the words get and set, followed by semicolons. And I keep on saying that I'm going to talk about what this public means. If you haven't figured it out already, you probably have. We're going to talk about it a little bit in this segment, and then in the following video, we're going to actually go into detail about what the public keyword means. So we have this public property of type string called name, and it has a getter and a setter. It looks very much like a field, aside from this getter and setter thing, right? And that is pretty much all there is to say about simple properties. Now, you might say, well, how could we make a property into a read-only property, right? The same way that we could make a read-only field. That seems like a useful thing to do. Now, if you were a sensible language designer, then you would say, well, you do it the same way that you would do it to a field. But unfortunately, that is not how C# does it. If you try to do this, then it says, oh, the modifier read-only is not valid for this item. It's a property. Read-only is only valid on fields. There's actually many different ways to make a field read-only, and they are subtly different. And we're going to talk about, if not all of them, at least most of them in this video. So in C#6, and I emphasize that this only works in C#6. This is a newly added feature. The easiest way to make a property read-only is simply remove the set, right? If you do this, then this tells the C# compiler that this is a property. It has a public getter, but that you should only allow the property to be set in the constructor, just the same way as a read-only field is only settable in the constructor. Right? And this is probably the best way to make a read-only field if you're in C#6. Now, you are not necessarily using C#6. It's because it's brand new. All right, a second feature that was added to C#6 is you can also give an initial value to a property, just right in line, the same way that you would give an initial value to a field. And the way you do that is you say, well, I want my string property, so the type and then the name. Then you say whether you want getters and setters. And then you give the equal sign and the value that you wish to assign as the initial value of the property. And again, this is only legal in C#6. This syntax is new. You can do it with read-only properties or with read-write properties. Either is perfectly fine. But in versions of C# before C#6, you can't put the initializer here. You have to put it in the constructor. So what would you do if you either felt like being verbose or you were using a version of C# like C#5, for example? The most common technique to make a read-only property in C#5 was to make a public property that has a private setter. Right? So this is saying I have a public property. It's of type string. It's called name. It has a getter. It also has a setter, but the setter is private. Right? And so the setter can only be accessed from within the class, but the getter can be accessed anywhere. Now, you might be wondering, what the heck is the point of this thing? Like, it looks like properties are exactly like fields, except that they are confusingly different in some very small ways. So for example, the way that we make them read-only is different. The fact that properties are usually public and fields are usually private is different. The fact that properties are usually named starting with a capital letter and fields are usually named with a small letter is different seemingly unnecessarily. Why do we have two different things that are so similar? Well, the reason is that properties, as we've been using them so far, are very, very much like fields, but they're actually halfway between fields and methods. Right? So let's make a property that is a little bit more like a method and a little bit less like a field. So this is how properties were done in C# 1. Right? So what we would typically do is we would have a backing field. Right? So this would be a private field of type string. Right? And then we would have a public property of type string called name. The getter would be a method. Here's the method body. You'll notice there's no semicolon here now. The getter would be a method that returns the value of the field. So again, we've omitted this dot, right? But we certainly could have that there if we wanted to. The setter would then say, well, if the value that we're trying to set this property to is null, then throw an argument null exception. If the value is white space, then say, oh, well, that's an invalid name. Otherwise, assign the field. Right? So you can see here that we've done a bunch of things. First of all, the value of the property is now associated with a very specific thing, is associated with this field. Second, we can now put logic in here, the same way we would put logic in a method. And that logic can say, you're only allowed to make certain kinds of assignments here. I'm going to throw exceptions if you don't follow my rules, and so on. So this is actually a really powerful technique. Right? This essentially allows you to write fields that verify that their contents are what you expect them to be. Now, a brief note about this backing field here. Some people use the convention where they have an underbar before the name of the field. And that's just kind of a little visual cue to them that says, oh, this is the backing field for this property over here. And that makes sure that they never accidentally make the mistake of using the backing field where they intended the property, or the property where they intended the backing field. And that's perfectly fine. I do this myself occasionally. I tend to make my backing fields just have normal names without underbars. The one thing that I would caution you is never begin a backing field or anything else in C# with 2 underbars. The reason being, the compiler team has reserved the right to make anything that begins with 2 underbars mean anything that they want. And this is a little escape clause in case the team ends up writing themselves into a corner somehow, and they absolutely need to add a new feature to the language, and they want to do so in a manner that does not break any existing code, but they're worried that they might break existing code. They can always make a new feature where there's a keyword that begins with 2 underbars, and know that no well-behaved programmer has ever made a program where they depended on an identifier beginning with 2 underbars, because the compiler team has said, nope, anything that begins with 2 underbars is ours. So please try to avoid beginning anything with 2 underbars. And this applies to more than just C#. There are other programming languages as well where the designers have decided to make this restriction. All right, so what are some good practices for writing these sort of method-like properties instead of field-like properties? Good advice is the getter should never throw. Right? It's totally fine if the setter throws. Right? The setter can say, hey, you're trying to set me to a value that I don't accept. You shouldn't have done that. I'm going to throw this exception. But a getter should always just say, here you go. Here's the value. Right? And there's a couple of reasons for that. One is it seems really weird to ask a class for, could I have this property, please? And it comes back with, no, you can't have that. You were wrong to ask, and I'm going to blow up now as a result. The second reason is you might have noticed, or maybe not, but when we were in the debugger looking at the values of things, the debugger displayed the values of properties automatically. And that means that it's actually calling the getters and setters automatically on your behalf. And if one of those getters should throw, then you have thrown an exception inside the debugger. And the debugger will handle that just fine. The debugger was written to be robust, to handle the situation where an exception is thrown when it's trying to evaluate a property. But what it will display is the value of this property is an exception was thrown. Right? And that is almost certainly not what you want, and it's very irritating. So try to make your getters always just return a value, and your setters can produce exceptions if they want. Another important guideline, people generally expect getters and setters to both be fast, for some definition of fast. You don't expect that if you call a property that it is going to try to fetch the value of that property out of a database, or try to hit some website in Japan, or something like that. Something where the value could take quite a while to compute. Generally speaking, you want properties to be sort of on the same order of magnitude as just fetching a field. It should be nanoseconds in order to fetch the value of a property, or microseconds at tops. Finally, getters should have no side effects. Right? You should never ask something for a value and then have that produce some side effect somewhere. There are a few exceptions to that rule. Sometimes there are getters that there are a few exceptions to both these rules. For example, there may be a property that is expensive to compute and involves producing a side effect once, but once the value has been computed, then you just store it, and then every time on from that you fetch it. But generally, just try to avoid situations where you are doing anything expensive at all in a property getter and setter. And the final guideline, of course, is that properties should be logically properties of the class of the things that they're talking about. Right? Somebody's name, that's sort of a property of the player. Right? You would think about that as something that is strongly associated with that player. Properties are things like height and weight and color and things like that. Things that you should not have to think very hard about and should not take much time to compute. All right, so those are the simplest possible properties. Where things get a little bit more complicated is when we have properties that are of collection types. And so let's take a look at an example of that. I said in a previous video that this property here, we have a property called wordList of type list of string, was a poor design choice in a few ways, and now we're finally going to find out why. So the first thing I want to muse about is, should this thing even be a property of the game class at all? I just said that properties should be things like height and weight and color, things that you sort of look at a thing and you say, well, obviously that's a property of this thing, right? I think it's pretty clear that the player of a game is sort of characterized as a property of the game, is the list of words that the game is going to choose the word from. Is that a property of the game? Well, it seems like you could make an argument one way or the other, but it's not necessarily a slam dunk yes or no. So that would be my first concern, but that's not a very strong concern. I have some stronger concerns here. The big concern that I have is that this is a read-write property, but it's more than just a read-write property. It is a read-write property of a mutable collection type. And this is a bit subtle, so I want to illustrate this with an actual example here. Right? So we're going to create a new player. We're going to create a new game with the player associated with it. Great, that's perfectly normal, no problem there. The word list property is null, right? So let's create a new list, and we will change the word list. All right, so now the word list is has two things on it, hello and goodbye. Now, we can change the contents of the word list without changing this property, because remember, these are all reference types here. Right? We are referring to a particular word list. If we change that word list, then we have changed the thing that we are referring to. Right? So we could say, well, let's change that word list. We'll add later to it. Right? Well, now the word list has three things in it. Right? Hello, goodbye, and later. Right? Or we could say, you know what? I don't like that word list. I'm going to create an entirely different word list, right? One that contains banana and apple, and I'm going to stick that in this thing. Right? it seems like, and then we could go on and we could then say, well, I'm going to add cherries to that thing. Now, it would seem like we could take that word list, we could make a reference to it somewhere else, that other code could change it, and unbeknownst to it would be changing the word list of our Hangman game. It seems like there are lots and lots of ways that the user of this class could be changing that list, and why is that any of their business? Right? Is that actually a feature that we want of this class? Do we want to write down in the documentation that it is a by design scenario that users of this class should be able to change the list in any way that they see fit, either by mutating it or by supplying an entirely different list? This seems like that's maybe not a core competency of our Hangman class, and it seems like there's potentially issues here. Right? Why are we allowing this particular operation at all? The design principle that I'm getting at here is when you're designing object-oriented code, remember the whole idea is to find areas of complexity and eliminate them, or at least encapsulate them into a small box where only the people who are maintaining the class can have to worry about that complexity. It seems like we're allowing complexity to leak out into the world here in a way that does not necessarily serve the code that is going to be using our Hangman class as a service. Right? Or another way to put that would be any operation that is permitted. So in this case, either editing the word list by adding new items to it or by replacing it wholesale, that should be permitted by design. There should be some design document somewhere that says, yes, we want this to happen, and we're going to write tests to make sure that it does happen. I would much rather say, you know what? If we expose the word list, we are going to expose it in a read-only manner, both so that the reference to the particular collection cannot be changed from outside, and the collection itself cannot be mutated from outside, even without changing the reference. There's a bunch of different ways to do that, and I'm going to go through what a few of them are. All right. So here's one thing that we can do. We can say that this is now a read-only property. I'm going to get rid of the setter. I'm going to say this is a list of strings. It's called word list. I'm going to give it an initializer. Again, remember, these features only work in C#6, but we've seen how you could do the same sorts of things in C#5 just by moving some of this code into the constructor or by making a private setter. So anyway, we're going to initialize this thing with a new list of strings. Here's our collection initializer. So we're going to say the list consists of apple and banana. And now we can show how this thing can be used by the caller. I'm going to go back to our program class here. And now you see our attempts to change the value of the word list have now failed. Right? Now, we're now getting an error that says this property or indexer cannot be assigned to. It's read-only. However, it is still perfectly legal for this code to call add on that word list, because the collection itself is mutable. We can change it. Right? We can't change the reference that's being stored in the property, but we can change the collection that that reference is referring to. So this is an improvement, but it's still not great. All right. So how could we make this thing truly read-only? Well, there's a number of different ways we could do that. So here is one that I like. We could say, I'm going to make a backing field. I'm going to call it underbar word list to emphasize that it's a backing field. And I'm going to initialize it with this new list here. Right. Then I'm going to say that my word list is a read-only collection of strings. And now this is another collection type that we haven't talked about before. And this one is a little bit odd. Rather than being a collection itself, the way a list or an array or whatever is a collection of things, the read-only collection is just a wrapper around an existing collection. The read-only collection says, I am going to present to the world a view of this collection that exposes no way to change it. And if you attempt to change it, then I will throw an exception. Okay. So I'm going to say, well, this is a read-only collection of strings. And I'm going to give it the value of a new read-only collection of strings wrapped around this word list. And unfortunately, I have a red squiggly here. What's going on? A field initializer cannot reference the non-static field, method, or property word list. So we have the problem that I mentioned earlier. This is essentially accessing this .word list. Right? And now we need to make sure that this field initializer runs before this one, and that's potentially error prone, and so C# simply disallows it. So we can't put this in the property initializer, but we can put it in the constructor. So up here in the constructor, I'm going to say, all right, the word list property is hereby officially initialized to a read-only collection of strings that wraps the word list. Right. And now, if we come back into our program here, we see this one is illegal, right? We can't assign to this thing. And this one is illegal. A read-only collection does not contain a method called add, right? So now the list is well and truly immutable from the point of view of the code that is using the hangman class. From the point of view of the hangman class, the list is still perfectly mutable, right? It has access to the backing field of type list of string. It can mutate that thing to its heart's content. So that's all I wanted to say about properties for the purposes of this video, but I also want to talk a little bit about indexers. We saw in our episode about collections that there are some collections, like lists and dictionaries, that support that square bracket syntax for saying, I'm going to index into this dictionary with this key, or I'm going to index into this list with this integer and get a value out of them, or put a value into them. Right? And you can see here we create a new list, and then we say, well, I want the element 0 of that list. And so this is an indexer syntax here. Or with the dictionary, we can say, I'm going to create this dictionary here, and then index into it like this. Right? Now, most classes have properties. Almost all classes in C# have properties these days. It is rare to create your own indexer, and you typically do it only if you're writing a collection class. But sometimes it does come up, and it is so similar to writing a property that I figured I would just do a real quick example about it here. So here we have an example of an indexer. I've just created a little class called indexer example. The syntax for an indexer is just the same as the syntax for a method-like property, except that the name of the property is always this. And it's really not super clear why. This has always been one of the oddest features for C# for me. I've always thought that this syntax was a little bit weird. But anyway, you say public, and then the type that will be returned, and then this. And then you have an argument list that is in square brackets instead of parentheses, emphasizing that this is an indexer. Because remember, indexers always use square brackets. Right? So this is sort of a nice little mnemonic way of saying, oh, this is an indexer that takes a string that is a key. And then you can write a getter. And so here, for example, we're going to switch on the key. And we're going to say, well, if you put in doe, then you'll return the value of deer. And if you put in ray, and so on. And if we have a default case saying to return null. So we have a number of interesting features here. We've once again used the switch statement that we talked about in an earlier video. This is the first time that we've seen a switch statement that switches on strings. But you can see that it is just the same as switching on any other constant thing. You put case, and then a literal that is the constant. And you can have a default case. Also, you'll notice that our switch sections do not end with break. They end with return. They certainly could end with break. We could write this some other way. We could say string result equals null. Right? And then we could say result equals a deer, break. And then similarly here, we don't need the default case anymore. And then down here, we could just say return result. Right? Either of these styles, perfectly acceptable, perfectly fine. I just wanted to emphasize that you could, in fact, have a return in a switch statement, and that this would be a common way to write the code. I didn't put a setter in here. I don't want to belabor the point. You can have a setter the same way that you have a setter in a property. The setter has an invisible value, which is an invisible value parameter, which is the value being set. And you can use the key in the setter as well as the value. So using indexers, like I said, not super common in most C# code unless you are writing a collection. Of course, very common to call indexers, but not very common to write them yourself. So I'm not going to talk about them anymore in this course. Summing up, properties, we have been using them so far like they were fields, but in fact, they're a little bit like fields, they're a little bit like methods. Properties should be fast, they should be simple, they should be logically a property of the class. You should make your properties read-only if possible. Like I said, any feature that is not by design, is not documented and tested, should not be a feature of your class. So if you don't intend a property to be written, don't allow it to be written. Consider using read-only collections for properties of collection type. Another technique that we could have done would be to use an immutable collection. And we'll look at, in a future video, we'll look at some techniques for doing that with properties instead of using the read-only collection wrapper. And we've seen that indexers are essentially properties that take arguments in square brackets instead of round brackets, and that indexers are rare. So it's unlikely that you'll need to write your own indexer anytime soon.